What's up? Hey, this is Mr. Maestas here, looking straight at you, right in my camera, and we are gonna deal with simplifying radical expressions. Oh, I think I'm actually on the wrong slide here. There we go. Simplifying radical expressions. Radical really means just a square root or a root. It could be a cube root. You know, not a tree root, because we're dealing with math. Simplifying radical expressions. So a radical, dude, that's radical. Rewrite. So we're going to do here to simplify these. We're going to rewrite it with no powers inside the radical sign, which is called a radicand. That's bigger than the index, and the index is like a square root or a cube root. You know, if that number, whatever that number is, we want it to be lower than that. We're going to combine radicals, so we can combine them, and then we can also remove radicals from the denominators, and we'll do that one. We'll do a little bit of that today, but we'll do that one later. Okay, so got a lot of problems to run through. I'm going to try to run through as many problems as I can in this short little video and see what we can get out of it. Okay, so let's go. Let's do the first one here. Now, what I do is I think about this in my head, and I think, Mr. Maestas, what can I get? What can go into 32 that is a square root, that's a perfect square root? So let me take a look at this here. And, you know, I can think, oh, well, 16 times 2 is 32. So I'm going to take the square root of each of these separately, okay? So the square root of 16 is 4, and then I'm left with the square root of 2. It can't do anything. Well, that's still multiplied by 3. So I'm going to get 12 root 2, and this is simplified. Now, what if you're like, well, you know what, Mr. Mises, you're a bright guy, and you can think of that in your head, 16 times 2. What if I'm not that? What if I can't do that in my head so easily? Well, there is a method you could use called a factor tree that might help you get there. So here's what a factor tree looks like, and I'll do it real quick. I won't do it for every problem, but you can do it if you need to. So you just think of a number that that you can go into 32 quite easily. And I think 16. I mean, 2 is easy to go into 32. We know it's an even number. Okay. Or say you might think, oh, well, I know 32 is 4 times 8. Okay, 4 times 8, yeah, it is 4 times 8. But we can go down a little further, right? 2 goes into 4. 2 also goes into 8. 2 also goes into that, okay? So now we've got 32 reduces down to 2 times 2 times 2 times 2 times 2. You're going to take an even pair. Any even pair works. So we've got 2 even pairs and a remainder one. So this remainder one, this guy right here, this guy is going to stay in our square root. See him there? There he is. Okay? These guys are going to multiply all together to give you 16, which is going to end up being the square root, which is 4. Okay, so that works too. If you can't get it, you can do the factor tree. All right, I'm not going to use a factor tree in all these. I just want to show you that you could use it, and then all the other ones, I'm just going to kind of blast it out of my head. Yeah, that was a weird visual. Okay, so what do you do when you're simplifying these radicals? Where you're like, dude, these are radical. What do I do? Well, you just separate, just like I did before. You separate the square root among everything there, okay? So we're going to go square root of 24, square root of x cubed, square root of y to the 9, all right? Okay, so square root of 24 you need to simplify. So 24 is, what goes into 24? We got 4 and 6, right? And I don't think we can do it anymore because the 6 is 3 and 2, and that doesn't have any matches, okay, square. So we're going to go square root of 4, square root of 6 is going to give me square root of 4 is 2, square root of 6 is just square root of 6. Okay, so that's that part. Let's deal with the square root of x cubed. Now, there's an easy way and a good and a right way. So most of my students like the easy way. The right way is we'll get to the right way later, because this square root is a type of power, and I'll show you how that leads to what we're doing here. But I'm going to just show you kind of the what to do, okay? Because I know some of you are like, just tell me what to do, and I'll do it. Okay, calm down. Jeez, I will tell you. What you do is, all you do is you see how many times 3. Remember, this is square root. See how many times 2 goes into 3, and the remainder is going to stay in your square root. So, how many times does 3 go into 2? Once. Okay? So I'm going to have 1x out of the square root, and I'm going to have 1x in the square root. This got divided out, and then there's 1 left over. Okay? So like this, watch. 9 divided by 2, right? Because right here we're dealing with this. So 9 divided by 2 is 4 with a remainder of 1. This is going to be my power of y when I take it out of the square root. And this is the 1 remaining that stays in the square root. Now when you're dealing with square roots, you're really only going to have a 1 remaining, because we're talking about dividing by 2. But if this was a cube root or 4th root, then you might have more than that. All right, so then we're going to put all these guys together, and we're going to have 2xy to the 4th. So anything that's outside the square root stays outside the square root. Anything inside square roots stay in the square root. Square root of 6xy. And that is our answer. All right? Okay, let's take a look at another one. Okay, so why don't you try this on your own, see what you get. 50 is 25 and 2. So this is going to be the square root of each of these. Square root of 25 is 5. This stays in there. Can't do anything about it. We're going to take 6 divided by 2, and that's 3. So there's no remainder, so it's r cubed. We're going to do 11 divided by 2, and that is 5 with a remainder of 1. So t to the 5th, okay, this is my power. And then I have 1 remainder, so that stays in there. T to the 1. Okay, you see that? So my answer is 5r cubed t to the 5th square root of 2t. All right, you got it? Okay, see, I know you're on the other side going, yeah, Mr. Right, sis, I got it. I really do got it. All right, so here's the answer for this one. We're going to have 3 root 2. And then we're going to have x cubed, which is going to give me x square root x. And then y squared, well, that's just, 2 divided by 2 is 1. So we're just going to have no remainder. So that's just going to be y on the outside. Coincidentally, it's going to be an absolute value of y. I'll tell you why. It basically has to do with the square root of y squared is always absolute value of y. So just remember that. I'll explain this, why that happens, in a later video, but just remember that if you take the square root of a square, you get the absolute value, okay? All right, so this. All right, moving on up. Okay, we'll skip this one. You can write down and try it out, but I don't want to spend too much time on this. If you want to know what the answer is real quick, it's going to be 2 root, 2a to the 2nd, b to the 3rd, square root of 2ab. Okay, so that's the answer. Let's go on the next one. Okay, so now we got a cube root, right? So with a cube root, the cube root of 16 is actually 2. No, it's 8 times 2. The cube root of 8 is 2, okay? So then we're going to do the cube root of x to the 6th and the cube root of y to the 8th, and we're going to do the same thing again. So the cube root of 8 is 2. The cube root of 2 is just the cube root of 2. The cube root of x to the 6th, we're going to divide. 3 goes into 6 2 times. So that comes out. Okay, 3 goes into 8 2 times with a remainder of 2. Okay, 2 times with a remainder of 2. And we're left with 2x squared, y squared, cube root of 2y squared. Okay, so that one's a little different. You'll see a couple of those on your workbook tomorrow. Well, if you're in my class when we get to class. All right. Woo. Okay, so you can do this one. All right, I'll let you go and write that down. If you have any questions, again, we've got a lot of problems. I can't get through all of them. So if you want to write this one down and come to class, if you're in my class, come to class, and then I'll do that problem for you guys in class, okay? All right. So again, this is a practice one. We'll do that one in class if you want to ask me. Again, it's a cube root, so you're taking the cube root of 54, the cube root of 8 to the 9, the cube root of b to the 5th, and you're doing just like we did with the square roots, okay? All right, so let's see if we have the square root of a fraction. Square root of a fraction, what we're going to do with these is we're just going to take the square root of the top and we're going to take the square root of the bottom separately. Now, one of the rules that we have is that you cannot have a square root. We don't want to have a square root in the denominator. So whenever we see a square root in the denominator without a plus or a minus, we're just going to multiply the top and the bottom by that square root, okay? Let me change it to red here so you know that I'm doing something. So what happens here is that when we do that, we're going to have the square root of 3 times the square root of 3, and the square root of 3 times the square root of 3 is the square root of 9. With the square root of 9 is 3, so it kind of cancels out the square root, so we got 3. And then square root of 2 times the square root of 3, we multiply the insides and keep the square root, so we get the square root of 6. And this would be our answer. Voila! That's it, okay? Let's do another one. Oh, practice this. Practice this, Daniel-san. 5 over root 2. Again, multiply top and bottom by root 2. Root 10 over positive 2. See? How easy is that? Come on. All right. Keep going. Now, what happens if you're multiplying two things? Well, when you're multiplying two things, listen, just multiply the things that aren't in the radical and multiply the two things that are in the radical, okay? So we're going to get 4 times 2, which is 8, and then root 5 times root 8, which is root 40. Okay, now we still have to simplify the root 40, and 40 is 4 and 10, right? So we're going to square root each of those, and we're going to get square root of 4 is 2, and then root 10 we just can't do anything with. So, and the reason we can't do again is the only things that go into 10 are 2 and 5, and we can't take the square root of 2 or 5. 8 times 2 is 16, root 10. And that's your answer. Okay, so when you're multiplying things, just multiply the two things that are outside the radical and the two things that are inside the radical. Woo, I'm talking fast now. All right, cube root. Again, same thing with cube root. All right, we're going to cube root the 3, cube root the 2, then cube root the top, cube root the bottom. It doesn't change really anything about the problem, guys. Cube root of 6 over, actually, I have to multiply it by another cube root, right? You see why I have to do that, guys? Because it's a cube root. And a cube root is 3 things. Like we are 3 times 3 times 3. So if it's a cube root, we have to multiply by the cube root of 2 times the cube root of 2 because we need 3 of them in there. With the square root, it was just 2 of them. All right? So we're going to have the cube root of 3 times 2, which is 6 times 2 is 12, over 2. And that's how we get rid of that cube root in the denominator. Okay. Go ahead and try this. Multiply these together. We're going to have 5 times 2, which is 10. 6 times 3, which is 18. And then 18 we know is 9 and 2. Okay, again, we square root both of those. And we have 10 times square root of 9 is 3. And root 2 we got to leave in there. Right? It doesn't do anything. 30 root 2. All right. That's the last one. So that's it, guys. So check it out. Make sure that when you're doing these things, you're always watching what the radicals are. Dude, that's radical. Take it, multiply the radicals. All right. Make yourself a factor tree if you need to. It's all about simplifying the inside to find things that are perfect squares, because perfect squares, we can square root them, and they're perfect. We like things that are perfect, right? All right, that's it for me for this one. We'll catch you next time. Later.